Hello students, I welcome you in physics classes. Dear students, as you know that we have started our unit 8 thermodynamics and chapter 1 we have completed and now we'll start chapter 2 and its name is second law of thermodynamics. Dear students, first law of thermodynamics we have studied in chapter 1 and before starting second law of thermodynamics, we should know about limitations of first law of thermodynamics. So let us begin. You can see that there are three limitations of first law of thermodynamics on your screen. First one is heat always flows from hot body to cold body, but the first law does not indicate as to why heat cannot flow from cold to hot body. Students, it is simple that first law doesn't indicate the direction of heat flow. Okay, and this is the first limitation of first law of thermodynamics. Next, second limitation is it does not tell about the conditions under which heat can be transferred into work. And third limitation is also very important, that it does not indicate as to why whole of the heat cannot be converted into work. Dear students, you know that according to first law of thermodynamics, dq is equal to du plus dw. Means heat supplied is utilized to increase internal energy and to do external work. Now question is that why whole heat cannot be converted into work. Okay, so this is not indicated by the first law of thermodynamics. So these are some limitations of first law of thermodynamics, and now let us proceed towards second law of thermodynamics. Dear students, second law of thermodynamics has two statements. First is your Kelvin statement and second is Clausius statement. Kelvin statement is taken from heat engine and Clausius statement is taken from a refrigerator. So let us start its first statement, that is Kelvin's statement. So according to Kelvin's statement, it is impossible for any machine to derive a continuous supply of work by cooling a body to a temperature lower than its surrounding. Means we cannot cool a body to a temperature lowest than its surrounding. For example, the temperature of surrounding is 25 degrees Celsius. So you cannot cool a body less than 25 degrees Celsius. This is the meaning of this statement, that you cannot get a continuous supply of work by cooling a body to the coldest of its surrounding. And this statement of second law of thermodynamics is taken from heat engine. Okay students, and now this turn for second statement of second law, that is Clausius statement. And this statement is taken from refrigerator, and it is impossible for a self-acting machine, means it is working by its own only without help of external agency, to transfer heat from cold body to lower body. Dear students, as you know that what is the work of refrigerator? Refrigerator is transferring the heat from cold body to hot body. Okay, that means from objects to surrounding. And according to this Clausius statement, it is impossible for any self-aided machine to do this. Okay, so these are the two statements of second law of thermodynamics. I hope that these two statements are clear to you all. Now let us proceed towards the next topic, reversible and irreversible processes. So it is very simple topic. Reversible, as its name is suggesting, those processes which can be reversed. Okay, for example, freezing of water to make ice. You can make ice from water and water from ice. So that means this is a reversible process. Okay, similarly, melting of a chocolate. If chocolate will melt, then again you can freeze it by keeping in refrigerator. Is it or not? So that means these both processes are reversible processes. Irreversible processes means which cannot be reversed in backward direction, like a rusting of iron and exchange of heat between two bodies. Dear students, rusting of iron means if any iron piece is getting rusted, you can't regain its original configuration. Is it or not? And second, exchange of heat between two bodies. This is also your irreversible process. So these both are the definitions of reversible and irreversible processes. Students, now our next topic is heat engine. Heat engine is a device which is used to convert heat energy into mechanical work. So if you want to do mechanical work from heat energy, we are using heat engine. And in heat engine there are three parts of heat engine. First part is your source, means the hot body. Second part is working substance, and third part is sink, means the cold body. Okay, so the working of heat engine we can understand from its diagram. So students, I'm just zooming its diagram. You can see that there are three parts in heat engine: source, which is at temperature T1, and sink, which is at temperature T2. And already we told you that T1 is greater than T2 because source is hot body and sink is a cold body. So working substance means like your petrol, your diesel, whatever you are using in your vehicles. So that working substance is here. Okay, this is a working substance. So working substance will take heat, means Q1, from source, and it will convert some of the heat into work done, and rest of the heat will be rejected to sink. Once again, I am telling you that working substance will take some of the heat from source, it will convert some heat to work done, and rest of the heat it will reject to sink. So the heat which it is taking from source is called as Q1. Okay, so Q1 is the heat it is absorbing from source, and Q2 is the heat which it is rejecting to sink. So how much heat is converted into work done? So obviously W is equal to Q1 minus Q2. So this is the amount of heat which is converted into work done. So this diagram is showing everything. I hope it is clear to you all. Now let us find its efficiency. Students, its efficiency is very important. That what is the efficiency of heat engine? So you can see that it is defined as the ratio of external work to the heat absorbed by the source. So just now I told you what is the work done, that is Q1 minus Q2. And what is the eta, means efficiency, W upon Q1. So Q1 minus Q2 upon Q1. You can divide it separately. So it will be Q1 upon Q1 minus Q2 upon Q1. So Q1 upon Q1 will be equal to 1, and Q2 upon Q1 as it is. So this is the efficiency, which is very important. Eta is equal to, efficiency is denoted by this letter, we call it eta. If you remember, then viscosity coefficient also denoted by the same. So eta is equal to 1 minus Q2 upon Q1. Okay students, now one more question comes in exam, that why efficiency of heat engine cannot be 100%. So this is the answer, that efficiency of heat engine cannot be 100%, because if efficiency is 100% means 1, then Q2 should be equal to 0, which is not possible. Okay, any sink at 0 degrees Celsius is not possible. That's why efficiency cannot be 100%. I hope it is clear to you all students. And there are two types of heat engines. One is external combustion engine and one is internal combustion engine. External means in which heat is supplied to working substance by burning the fuel outside the cylinder, and in internal combustion it is burned inside. Okay, so mainly with the question which is asked in exam, I am telling you the question is always asked that what do you mean by heat engine? Calculate expression for its efficiency by drawing proper diagram. So this is the diagram which you need to draw. Students, this is the diagram which you need to draw. And second thing, this is the efficiency which you need to write. And third thing, this is the definition of heat engine which you need to write. So I hope that everything is clear to you. For any query, you are free to ask me. And dear students, I will share this PDF with you. You need to prepare notes. You need to write each and everything in your notebooks. Okay, for any query, you can leave message in comment box, or you can leave message on my WhatsApp number. So this is enough for today. Thank you. Have a good day.